components of expert system. So we shall explain that what are the different components which are required and who is actually interacting with whom, and that detailing will be described using one diagram at first. So here we are having this user. So one user interface will be provided so that the user can interact with the expert system. So what about the queries the user will generate? What are the respective user interfaces are getting? So that will be coming to this respective block, that is explanation facilities. And then we will be going for this inference engine, and this inference engine will be communicating with this knowledge base, also known as KB, where the different rules will be written in the form of if then. And this interface engine will be also communicating with the databases where the facts will be stored here. So in this way, from the user to this knowledge base and database, it will decide that what are the components we are having in our expert system. So now I think it will be better if we go for each and every component explanation into further details. So at first we are going for this knowledge base, where the respective rules will be written with the form of if then. It is a declarative representation of the expertise, often in if then rules, including such things as simple facts about the domain. So here this respective domain will be expressed in the form of if then rules. Rules or constraints that describe relation or phenomena in the domain, and possibly also methods, heuristic and ideas for solving problem in this domain will be done. And that is the concept of our knowledge base. So next one is our database, where the facts will be residing. So it is the data or a set of facts which is specific to a problem being solved, used to match against the if condition parts of the rules stored in the knowledge base. So in the knowledge base we are having the rules. These rules will be accessing these databases, and these databases will be having collection of different known facts. So the next component is our inference engine. So it carries out the reasoning by interplaying the information or facts obtained from the user with the knowledge stored in the knowledge base, whereby the expert system reaches a solution. So this inference engine is actually doing the communication between this knowledge base and the database. So information will be coming to this inference engine, and where it will get interpreted. We are going to have this explanation facilities. It explains about how a particular conclusion is reached and why a specific fact is needed, and also explains its reasoning and justifies its advice, analysis and conclusion. So this explanation facilities will decide that what are the different information is required and which information will be required in which order. So everything will be decided in this explanation facilities. So now we are having the last one, that is the user interface with which the user will be interacting. It provides communication between the user and the expert system. This user interface must be made as user friendly as possible, so that user will feel a very convenient environment to work and to interact with this expert system, so that the user will get the proper support and guidance from the expert system as well. Thanks for watching this video. Why expert system? That is a very vital question, and we shall search the answers against it. In the era of expert skill, every domain relevant expertise is desired. Major problem is scarcity and inaccessibility of real experts in a particular field. So that is one of the major problems we may face. For a particular domain, for a particular field, finding out the exact and appropriate experts is a challenge for us. Consultation is expensive and experts will feel the repetitive job uninteresting, which may affect the efficiency. So whenever one expert will try to go on doing the same job repeatedly, then monotonicity will be coming. So to get rid of the monotonicity, The job will become monotonous to the respective experts, so the performance may get degraded. Experts may feel memory limitation affecting processing of essential knowledge and information required for decision making. So obviously the decision which will be made by the expert will depend upon his or her memory capacity, how much he or she is knowledgeable. So that's why the decision will be varying from one expert to another expert. Researchers and developments in every discipline render relevant and accurate advice available from updated experts, which is not an easy task. So finding expert in the respective domain and getting this expert deployed into the particular domain and problem is always a big challenge for us. Experts are subject to limitations and it is impossible to access all the essential factors while taking decisions. In manual process, some factors may always be missed and unconsidered. Obviously, you should not trust on the manual processes. This necessitates computer-based tools for assistance like decision support system, decision making system or expert system to update knowledge and render help in making decisions. So that's why these systems have come into the play, and where we will be always updating its respective knowledge base and databases so that the decision whatever is going to be taken will be appropriate for the situation and the domain. Why expert system? If we continue with this particular topic, then every expert systems of today support system solving activities such as decision making, knowledge fusing, designing and planning, forecasting and regulating, that is also a very important issue, controlling and monitoring, and then identifying, diagnosing, pre-describing, interpreting, explaining or training using different techniques, while future expert system will support many more such activities. So here we are having a very limited list where this expert system can play its role. So in future also we are going to have so many different applications of expert system in our real life. Thanks for watching this. Application of expert system. Expert system is having application in different domains. So some of the domains we will be considering in this session. So in the domain of horticulture. So in this diagram it has been depicted that we are having agro clinic with expert system for local consultation. So these are the different counters and different offices are there, and they are actually communicating, or these systems are connected with this main server with complex expert system, and such main servers will be connected with the remote sensing centers connected with the different satellites for getting different information from different zones and locations. So here we are denoting that how in the domain of horticulture the expert system can be applied. In the domain of horticulture, the computer-based general farm management and expert system can be helpful in providing solutions to the problems in the horticulture. So those people who are related with the horticulture, they are facing different problems and issues. They will be coming to the local consultation centers to get the required guidance. Expert system can provide a comprehensive management in disease, pest and disorder management of the plants. So different kinds of pest related problems, different kinds of diseases of different horticulture elements. So those things can be managed in a very comprehensive way with the help of this expert system. Since plants and fruits are affected by insect pests and diseases which causes considerable loss if not properly managed, and in some location there might be some tendency which is seasonal. So in those cases obviously we must not be reactive, but we should remain proactive for that, which will be also helpful to increase total production and minimizing the respective losses. Computer-based general support and expert system can be helpful in creating awareness and giving timely preventive suggestions. So if we can predict that this sort of diseases or pest related problems are coming, if we have that tendency, if we have the required trending, then obviously the preventive measures can be taken beforehand. It can also help in insect identification, monitoring, insecticide selection and disease management respectively. It can be cost effective as users need not to wait for the experts, because there will be some expert system from where we will be getting all such guidances and information. By repeated consultations, farmers can develop self-skill and awareness for caretaking, and expert system can become advisory cum training tools. So what will happen when the corresponding farmers and corresponding people related with horticulture will be going to the local consultation centers, then without consulting with the actual experts, physical human being experts, expert system will give the required consultancy and guidances, and in this way the respective people who are involved with this horticulture will get also the required training. The transfer of knowledge from consultants, scientists, researchers and experts to extension workers in any area is very important for development of agriculture and also horticulture. So when the people related with this horticulture or agriculture, if they are getting enough knowledge through the consultation, then obviously the most of the problems will be solved at their end only. Let us go for the next topic or the next domain where expert system can be applied, and it is having a very sincere role, that is our medical diagnosis and expert system. Pathology is the study of the origin, nature and course of diseases. Pathology reports explain the outcomes of tests on the patient and the diseases various information. So you know that we always go for the pathological tests when you suffer from some disease, and these test reports are very vital for the medical diagnosis. Pathologists were in need of a comprehensive interpretative service to help them interpret these reports. So expert system can play its role so that it can infer regarding the probable diseases. Next we are going for this PIRIS. So that is Pathology Expert Interpretative Reporting System. So that is a full form. Pathology Expert Interpretative Reporting System. So PEIRS was created as a user maintained expert system for automating the interpretation of chemical pathology reports. So it will generate the chemical pathology reports through this respective expert system. The system uses over 2,500 rules to generate interpretive comments on the reports. That means this particular expert system was having 2,500 plus number of rules which will go for interpretative comments on the reports generated. So in this way, expert system can play a very vital and productive role in our medical diagnostics and pathological tests. So next we are going for Patriot missile. This particular missile can have another name, that is SAM, that is surface to air missile. This missile is now being used by US Army and also by different allied nations. This missile was developed by US defense contractor Raytheon, and this missile has got its name, which is actually similar to the radar system used in this weapon. So it does all the work of the Stinger and Sidewinder, but faster and more efficient from a longer range and without the need of an expert. So in this session we have shown you that what are the different fields of applications of expert system in our real life. Thanks for watching this video. Let us discuss one case study. The case study is a robot visits a zoo. A robot will visit a zoo with certain knowledge base, and knowledge base concerning 7 animals. So let us discuss animal wise that what are the required information are there with the robot. So at first we are going to discuss that tiger. So a robot visits a zoo with the following knowledge base. So the first knowledge base regarding this tiger. So robot knows that a tiger has hair, gives milk, eats meat, has pointed teeth and has claws, has forward eyes, has tawny color, has black stripes. Tawny color means yellow color. So that's why this particular robot is having such information regarding one tiger. So next one is a giraffe. So it is ungulate, has long neck, has long legs. So this is our animal number 2, that is giraffe. Let us go for the other 5. Next one is our zebra. The required knowledge base concerning with this ungulate and has black stripes, and obviously the zebra is having the black stripes on white. So here we are having our next animal, that is ostrich. So it is a bird, does not fly and has long neck. Next one is our penguin. Bird, does not fly, swims, is black and white. So this is the respective knowledge base against penguin. But having the next one, that is albatross. It is a bird, appears in story Ancient Mariner and flies well. So this is the respective knowledge base with the robot regarding this albatross. The next one is our cheetah. So it is mammal, carnivore, has tawny color and has dark spots. So this is all this information with these 7 animals are there with the robot, but how they will be framed. So that's why the robot will have the following set of rules. So we are having multiple rules. So let me discuss one by one. Rule number 1, if animal has hair or if the animal gives milk, then animal is a mammal. So all these rules are to be remembered and they are to be written in the respective prologue clauses. So rule number 2, if animal has feathers or animal flies and animal lays eggs, then animal is a bird. So that is our rule number 2 here. Rule number 3, if animal is a mammal and animal eats meat or animal has pointed teeth and animal has claws and animal has forward pointing eyes. So here we are having the respective clauses, the respective reasons for which we can tell that this animal is a mammal. Then animal is a carnivore. Rule number 4, if animal is a mammal and animal is a carnivore and animal has tawny color and animal has dark spots, then animal is a cheetah. So in this way the inference will be made by the robot. Rule number 5, if animal is a mammal and animal is a carnivore and animal has tawny color and animal has dark stripes, then animal is a tiger. So we are how to infer that this animal what has been visited by the robot is a tiger. So here the respective conditions. Next one is our rule number 6. If animal is a bird and animal does not fly and animal swims and animal is black and white, then animal is a penguin. So that is our rule number 6 here. Rule number 7, if animal is a bird and animal has appeared in story Ancient Mariner, then animal is a albatross. So that is our rule number 7 here. Let us go for the rule number 8. If animal is a bird and animal does not fly and animal has long neck, then animal is a ostrich. So in this way we are making all these rules framed. Next one, the rule number 9, if animal is ungulate and animal has long legs and animal has long neck, then animal is a giraffe. So in this way we have formulated the respective rules for all 6 animals. Let us go for the last one. So rule number 10, if animal is ungulate and animal has black stripes, then animal is a zebra. So that is the last one. So in this way the robot can infer that the animal does visitate, which is satisfying all these conditions, will be one zebra. We shall have to design one expert system to recognize these animals while visiting the zoo. So whatever we have discussed, let us write one Prolog program and let us show you that how the program will work and how the coding has to be done. So here is the demonstration for you. Please watch the demonstration and get the conception that how to implement such problems in Prolog. In this program, a robot visits a zoo, and while visiting, the robot has interacted with multiple different animals. So here the main executable query will be our visit zoo predicate. So we shall call this visit zoo predicate in our query. Okay. So now it is calling this predicate hypothesize. So here we are having hypothesize cheetah, tiger, giraffe, zebra, ostrich, penguin, albatross, and in case of unknown animals it will be traced. Okay. So cheetah must have these following properties. Tiger must be having these following properties. So all these properties must be true for the tiger. So here we will be taking input from the keyboard from the user, whether this tiger, the corresponding animal, is having the tawny color or not, whether that animal is having the black stripes or not. In this way we shall be taking the inputs from the keyboard. Okay, so here we have written all the respective predicates. Okay, now see, mammal means verify whether it is having hair or not. Mammal also indicates that it gives milk, so I shall be verifying all these things accordingly. So here we are having one predicate known as ask. So how to ask question? So does the animal have the following attribute? Write question mark, and read response. And in this case this response will be either yes or no, and if this response is yes or y, this semicolon indicates OR logic. So assert A yes question or assert A no question and fail. So here assert A actually it first converts the term clause to a clause and then adds it to the current internal database. So what is happening here, this clause is nothing but this one. So this clause will be added dynamically onto our Prolog database. So we know that all the procedures can be divided into two categories. One is a dynamic and another one is a static. So using this dynamic, we are defining that this yes and no are the two procedures which are going to be defined when the program is running. That means yes and no are the dynamic procedures. So that's why we have used this dynamic. Okay, now here we are going for the verify. So in case of yes, I shall be going for true. In case of no, I shall be going for fail. And before leaving, I should undo all the yes and no assertions. So the respective codes are written accordingly. So let me execute my program for the better understanding and the clarity of the logic. Okay, now say I'm executing the query, that is visit zoo. So I'm pressing enter. So questions are being asked. So what is the first question? Has hair? I'm telling no. Gives milk? I'm telling no. So that means it is not a mammal. Has feathers? I'm telling yes, it is having feathers. That means it can be a bird in that case. Does not fly? No, it is not true, it can fly. Appears in story ancient mariner? In that case I'm giving the answer yes. Okay, flies well? I'm giving the answer yes. So it is suggesting that I guess that the animal is albatross. So in this way I'm getting this idea. Let us go for another case study. So I'm going for this visit zoo query execution again. Okay, so has hair?
I'm telling yes. Eats meat, I'm telling yes. Has tawny color, I'm telling yes. Okay. Has dark spots, I'm telling yes. So it is a cheetah. I guess that an animal is cheetah. So in this way, my program is suggesting, depending upon the queries generated and answer received, what is the respective animal the robot has seen and has visited. So we have shown you the respective program code and the execution of the code as well. So you can write this code at your end and go on executing, and you'll be getting such answers in a very intelligent way. Thanks for watching this video.
Problems and advantages of expert system. So the first aspect we want to discuss here right now is known as the ethical implications. Do you want to put a decision about your life in the hands of a computer? So regarding a very important decision in my life, should I trust on a computer's decision which is coming as output? When do you think you would trust a computer's judgment over a doctor's? So let us suppose regarding one patient's treatment, a doctor's judgment is differing from the expert system's judgment. So which one to follow, which one to trust, and which one to implement and carry forward? So at first we are going to discuss the problems with expert system. Unavailability of expert in the field. In a certain field, in a certain domain, sometimes it may happen that the respective expert system is not available. The expert is unable to communicate his her ideas. Whatever the user has asked for, what are the ideas the user has shared, the expert system is not in a position to communicate with him or her accordingly. The expert is unwilling to communicate his or her ideas. The expert system is not willing, the expert system is not in that respective phase so that it can communicate with the user with respect to the his or her ideas has shared. Must have all information on the subject. Sometimes expert system may have a very shallow knowledge base, may have a very shallow database, not having crystal clear idea regarding the subject domain. In those cases, obviously, the inferences whatever the expert system will provide us may not be trustworthy. Can all the testing be accomplished? So that is a very vital question, whether this expert system, whatever the required output we are getting, has it been tested thoroughly? The last one is the user acceptance. So these are the very major problems with the expert system. So now we are going for the advantages of expert system. First one is can be simple to use. Next one is efficient results, accurate results. So here we are judging that this expert system is having a good knowledge about the subject, the knowledge area is widespread, and the expert system is thoroughly tested with some real life problems, so we can trust on the outputs and inferences made by the expert system. Adaptation and adjustments to changing conditions, and it is cost effective. So these are the different advantages of using expert system. So in this session we have discussed the problems and the advantages of expert system. Thanks for watching this video.